All right, so in the previous lesson, we talked about thermal expansion and thermal contraction. Thermal expansion and contraction are basically these two processes that are a result of heat and cooling, right? Heating causes expansion. The objects that tend to increase in size, they tend to become bigger, they expand, right? And that is because the vibrations are greater when molecules are heated. So, and when the vibrations are more, the molecules they take up more space, they move faster, they become greater in size. This is because the intermolecular forces are lesser. The molecules expand, and contraction is exactly the opposite of this. This is why some of the structures like bridges, metallic structures, towers, they tend to expand in summers and their heights contract in winters. We're going to look at thermal capacity now. Now you see this expansion is a result of heat. How much heat an object can take in, and then because of that heat, the object basically expands. Now, how much heat can an object take in? This concept is known as thermal capacity. When the temperature of a body rises, its internal energy increases, the molecules vibrate more. This is a concept. This is basically how this line explains how the vibration is greater because the internal energy is more. One thing to remember here is that the internal energy is the sum of kinetic and potential energies. So this concept of internal energy states that when you add all the kinetic plus potential energies of a system, you get the internal energy. Now, even one of the energies increases, the total energy, the internal energy would also increase. For instance, if kinetic energy increases and potential remains constant, the internal energy would increase. Similarly, if let's you keep kinetic constant and you increase potential energy, the internal energy would also increase in that case. So this is how we come to the concept of specific heat capacity. Specific heat capacity is the amount of energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius. So for the experimental analysis of heat capacity, specific heat capacity, we look at 1 kg of a substance and we look at a temperature increase of that by 1 degree Celsius. So you analyze basically a stated quantity of a substance, 1 kg in this case, and you see how much energy you need for it to increase 1 degree Celsius in temperature, right? The difference basically is when you're given with, let's say, different substances of different composed of different materials. In that case, if you keep the mass constant and you look at a temperature change, this is known as delta T, 1 degree Celsius. And then you see how much energy would be needed to basically achieve this change in temperature. So that is basically the change in thermal energy. The formula we use for this is mc delta T. I'm going to write it here as well. Delta E, change in energy, is mc delta T. M is mass, C is specific heat capacity, delta T is temperature. So if you want to, let's say, figure out specific heat capacity, you're going to make the subject. So delta E, sorry, uh, yeah, delta E over m delta T is equal to C. So this will be the formula for specific heat capacity. Remember, C is the specific heat capacity over here. So you need to remember that for specific heat capacity, temperature is in degrees Celsius, mass is in kgs. ठीक है, ये आपके units पता होने चाहिए. Mass is always in kgs and temperature is always in degrees Celsius. Okay, I think that's pretty much it. Moving forward, Acha, so you'll basically be applying this equation for different questions regarding specific heat capacity. इसमें होगा, you might be given with masses, temperature changes, and you'll be asked to figure out the specific heat capacity, or if you, let's say, would be given with specific heat capacity, you'll be asked to figure out the changes in energy. So this is all that you need to know You need to remember this formula, the units, and how this is applied. We'll also be looking at a few questions after we're done with this lecture. So yeah. Moving on, melting and boiling. So melting and boiling occur when energy is put into a body without a change in temperature. Again, changes of states. One property for changes of states is that the temperature does not change. The temperature remains constant. This is a fact. And melting and boiling are both the results of heating. आप एक ऑब्जेक्ट को हीट करते हो, the object melts. You heat it further, it boils. Melting point is the temperature at which a given solid will melt when heated, or I mean, turning of solid into liquid. This is melting. Boiling is liquid to gas. Boiling point is the temperature at which a given liquid will turn into a gas when heated. Yeah. Yes, standard temperatures. Melting point of water is 0. Boiling point of water is 100, right? Okay. Condensation. Ab condensation is basically a result of cooling. Okay? Melting, heating, yeah, melting or boiling to heating ka result hai. This is a result of cooling. When some molecules in a gas do not have enough energy to remain as separate molecules, so they come close together and form bonds, becoming liquid. So condensation is when a gas turns into a liquid, right? The bonds basically, they join again, okay? Gas the molecules they come close together, the bonds join and they become a liquid. So this is what condensation is. इसी तरह से freezing. Freezing is also a result of cooling. When molecules in a liquid slow down enough that their attractions cause them to arrange themselves into fixed positions, becoming solid. So now liquid to solid is freezing. तो अगर हम इसको सिंप्लीफाई करें सबको, तो you have a solid turning into a liquid and liquid turning into a gas. Solid turns into a liquid through melting. Liquid turns into a gas through evaporation or boiling. Gas then turns into a liquid through condensation. And liquid turns into a solid through freezing. Okay, so this was important. Evaporation is different to boiling because it can happen at any temperature and only occurs at surface of liquid. We've already done that, I think. We can move forward. So specific latent heat is the amount of energy needed to change the state of 1 kg of a substance. Yeah, so latent heat दो तरह की होती है, latent heat of fusion और latent heat of vaporization. Fusion, vaporization. अब latent heat में हम ये देखते हैं कि you're changing the state. Solid है तो वो liquid बन रहा है, liquid है तो gas बन रही है. तो आपने देखना होता है if you have 1 kg of a substance, how much energy would that 1 kg of substance need to change its state? For example, अगर आप if you're talking about fusion, तो fusion का मतलब ये है कि you're either talking about a liquid turning into a solid or a solid turning into a liquid. दो ऑप्शंस हो सकते हैं, मेल्टिंग या फ्रीजिंग. ठीक है, वेपराइजेशन की जब बात होगी, वेपराइजेशन में either a gas turns into a liquid or a liquid turns back into a gas. So it's boiling or condensation, right? So these are two phenomena that are basically true for vaporization. तो फ्यूजन वेपराइजेशन ये लेटेंट हीट से, इसका जो फॉर्मूला है इट इज ml. E is energy, m is mass, LF या LV. LF तब यूज होता है जब लेटेंट हीट ऑफ फ्यूजन की बात हो रही हो, LV तब यूज होता है जब लेटेंट हीट ऑफ वेपराइजेशन की बात हो रही हो. तो इफ यू लेट्स से सपोज टू राइट अ फार्मूला फॉर लेटेंट हीट ऑफ फ्यूजन, तो आपका फार्मूला होगा E is equal to mLF. ठीक है। अगर आपकी वेपराइजेशन की बात हो रही है तो आपका फॉर्मूला होगा E इज इक्वल टू MLV. LF इज लेटेंट हीट ऑफ फ्यूजन, LV इज लेटेंट हीट ऑफ वेपराइजेशन, राइट। अगर आपने इनको सब्जेक्ट बनाना हुआ, LF को अगर हम सब्जेक्ट बनाए तो आपका बन जाएगा E/M. LV को भी बनाओगे तो सब्जेक्ट बन जाएगा E/M. तो लेटेंट हीट का जो अपना फॉर्मूला है वो एक ही है, एनर्जी ओवर मास। लेकिन जब हम फ्यूजन और वेपराइजेशन की बात करते हैं तो उनको रीअरेंज कर लेते हैं, ठीक है। मूविंग ऑन, when a body changes state, energy goes towards making the molecules more free from each other rather than increasing their kinetic energies. So इसी वजह से टेम्परेचर कांस्टेंट रहता है, राइट। लुक एट दिस कर्व, दिस इज अ हीटिंग कर्व। ए पे क्या है, टेम्परेचर लोएस्ट है, बी पे टेम्परेचर इंक्रीज हुआ है। तो इसका मतलब ये है कि यहाँ पे जो ऑब्जेक्ट उसकी स्टेट अभी चेंज नहीं हो रही, क्योंकि टेम्परेचर चेंज हो रहा है। जहां जहां टेम्परेचर चेंज होगा वहां पे स्टेट चेंज नहीं होगी, और जहां पे टेम्परेचर कांस्टेंट होगा, जैसा यहाँ पे बी से सी तक टेम्परेचर कांस्टेंट है, डी से ई तक टेम्परेचर कांस्टेंट है, दिस इज वेयर चेंज ऑफ स्टेट इज हैपनिंग। वी गोना सी कौन सी चेंज ऑफ स्टेट हो रही है। तो ए टू बी इज बेसिकली जस्ट सॉलिड, आइस है, राइट। सॉलिड है, आइस है। व्हाई? बिकॉज दिस टेम्परेचर चेंज हैपनिंग। सो आइस का जो टेम्परेचर इज जस्ट इंक्रीजिंग, so increase in temperature, the substance remains as it is. BC पे क्या हो रहा है कि this change of state happening, so this ice is basically turning into water. अब यहाँ पे क्या क्या मौजूद है, यहाँ पे आइस भी मौजूद है, सॉरी यहाँ पे सॉलिड भी मौजूद है, और यहाँ पे लिक्विड भी मौजूद है, क्योंकि दिस इज एन इंटरमीडिएट स्टेट। यहाँ पे चेंज ऑफ स्टेट इज हैपनिंग। C to D the temperature again increases, so increase in temperature, किस चीज का टेम्परेचर इंक्रीज हो रहा है, जो लिक्विड है, लिक्विड रिमेन एज इट इज, वाटर। D से E पे the temperature is constant, so another change of state, या हीटिंग है तो इसका मतलब है liquid to gas, liquid to gas का मतलब क्या हुआ कि it's boiling, या boiling happening. Remember evaporation का there's no point, there's no specific temperature, evaporation कहीं भी हो सकती है, boiling का there is a specific temperature. तो यहाँ पे जो change of state है, you cannot write evaporation here, you'll write boiling, because we're talking about a specific temperature of the y-axis, right? So moving on, अच्छा यहाँ पे टेम्परेचर्स को यू कैन फॉरगेट दिस, ये आपके इतना इंपॉर्टेंट नहीं है, थर्मोकपल चीजें। Coming back to the thermal processes, we've already done this in detail. I'm going to just leave it here for you to review. You can take a screenshot, you can pause the video, take a screenshot of it, right? Conduction, convection, radiation, these are the three energy transfer processes जिधर से energy transfer होती है। Now we're going to have a look at some definitions. States of matter में solids, gases, liquids की हैं. I think we've already studied this. Brownian motion. It is random motion of particles suspended in a medium. This is Brownian motion. Gas temperature है, kinetic molecular model of matter. You already know that. Pressure है. We can maybe focus on internal energy. Internal energy is basically the energy stored by the atoms and molecules that make up a system. It is equal to the sum of the total kinetic and potential energies of the particles in the system. Yeah. वही जो हम बात कर रहे थे, kinetic plus potential energies. Thermal capacity is defined as the amount of heat to be supplied to a given mass of a material to produce a unit change in its temperature. Specific heat capacity. The amount of energy needed to increase the temperature of 1 kilogram of substance by 1 degree Celsius, specific heat capacity. We're talking about C. Yeah. You already know what boiling point, condensation, evaporation, melting point, solidification. Solidification is just a phase transition in which a liquid turns into a solid when its temperature is lowered to or below its freezing point. As the molecules lose heat, they lose their kinetic energy and band together. So this is solidification, how a solid liquid turns into a solid, basically. Yeah, I think that is it. Baki, you can just read through the definitions. I'll share this. I think this document is already shared with you in the group. So yeah, that is it for now. The next topic, I mean, before we move on to the next topic, you'll be getting a follow-up assignment from this lecture.